All right, this is my Chapter 5 original problem. So steam enters a nozzle at 10 meters per second, and it's at a at a temperature of 600 degrees Celsius and a pressure of 40 megapascals, and with a volume flow rate of 5 meters cubed per second. The steam exits the nozzle at 375 degrees Celsius and 30 megapascals. 20 kilowatts of heat enters during the process. What is the velocity of steam and the area of at the nozzle outlet? So we're going to start with our mass flow rate. Our mass flow rate, since it's a steady flow process, mass flow in equals mass flow out, which is just equal to the mass flow rate. And now our energy balance, E in is equal to E out. So that would be the heat in plus the mass flow in times enthalpy at state 1, specific enthalpy at state 1, plus the velocity of steam at the inlet squared over 2, and that is the kinetic energy, and then that's equal to energy out, and that's equal to mass flow rate times and specific enthalpy at the outlet plus the velocity of steam at the outlet right there. So now checking off, we have from table A6 with the values that were given in the problem, and knowing that this is a superheated water vapor. Specific enthalpy, this is 1 right here, and that's at the outlet. So specific volume at 1 is 0.008089 meters cubed per kilogram, and specific enthalpy is 3,350.4 kilojoules per kilogram. And at the outlet, which is 30 megapascal, 375 degrees Celsius, specific volume is 0.001792 meters cubed per kilogram, and specific enthalpy is 1791.9 kilojoules per kilogram. So checking off what we have H1, we have our V1, which was given in the problem. We have H2. We're looking for V2. So what we need, and we also have our heat in. So we need to find our mass flow rate, which we can find because in the problem, we were given a volume flow rate, and in our table at state 1, we have our specific volume. So the volumetric flow rate divided by the specific volume at 1 is equal to the mass flow rate, and that's also equal to the mass flow rate of the process of the system. So it's the same at the outlet. So now dumping everything into our energy balance, we have 20 kilowatts plus 618.12 kilograms per second, which is our mass flow rate, times H1 plus V1 squared over 2. And then keep in mind you have to divide by 1,000 to convert it from meter squared second squared into kilojoules per kilogram. And then on this side we have the same mass flow rate, H2, and then V2 squared over 2. And this was just, I combined everything on the left side there to be 2,071 megawatts. I divided that by 618 from there. And then from that point, this right here gave me this. And then I subtracted 1791.9 from the right over to the left, so I subtracted it. And then I multiplied it by 2. And and I took the square root of it. So V2 yields 55.83 meters per second. So that's the velocity of steam at the outlet. And now we need to find the area at the nozzle outlet, and then as well as the inlet. So the area of the nozzle outlet, we have our mass flow rate, and to find area, we are going to need the volume flow rate. And to find the volume flow rate, we know that our mass flow rate is the same at the inlet as it is the outlet. And from our table A6, we have the specific volume, which is 0.001792 meters cubed per kilogram. And we are going to multiply our mass flow rate by our specific volume to give us our volume flow rate, which is equal to 1.108 meters cubed per second. And then we are going to divide, to find our area at the outlet, we are going to divide the volume flow rate that we just found, 1.108 meters cubed per second, by the speed of steam at the outlet, which we calculated in part A. So 1.108 meters cubed per second divided by 55.83 meters per second, that will give you 0.0198 meters squared. So that's the area of the nozzle outlet. And then the area of the inlet, basically we have our velocity, which was given in the problem, 10 meters per second. And we are going to divide the volume flow rate, which was given, which was 5, by the velocity, which was 10 meters per second. So 5 meters cubed per second divided by 10 meters per second, that's equal to 0.5 meters squared. So that is the area of the nozzle at the inlet. Thank you for watching, and have a nice day.